Hello everyone and welcome to the Disruptive Innovation Festival, the online festival that asks the question, what if we can redesign everything? We are already in the end of week 2 with a new day full of sessions. And here's this, 3D printing, the technology rooted from the 80s already. Back then it was mostly used for prototyping and it's still growing in popularity with more and more use cases every day. And more materials being used, production getting efficient. And that's what we're going to talk about today, together with Massimo, Helge, Sophie, and Tiziano from the B Corp certified organization design company Keenbull. They're focused on asset organization and the social environmental impact on it. So this is an interactive session. Remember that you can ask all your questions and post your comments on the comment box below this session, this video, or tweet using the hashtag ThinkDiff. That's it for me for now. Over to Tiziano.
Thanks Kinga, and welcome to our session. And I am Tiziano, nice to meet you all. And with Keenbull, we are involved in applied research projects around additive manufacturing, automation, and social innovation. In these projects, we are collaborating with universities and industrial partners all over the world, and we are facing new challenges every day. As Kinga said, the technology itself is growing to its maturity. But these new challenges, we are putting us in very unknown territories very frequently. Today, we are trying to share with you our very personal experience in being there in this outpost for the big changes happening with this manufacturing methodology. And I will start my session just introducing you to the industrial side of 3D printing. We are focused on the industrial sectors. And then I will leave the floor to my colleagues. They are going to face 3 specific aspects of additive manufacturing or 3D printing. So the term, let's say that for this session, the terms are the same. So we are, of course, we want to also to reply to your questions, as Kinga said, maybe at the end of the speech, or just commenting to your comments in the box below. So when we start talking about the industrial sector, we are referring to 3D printing as the process for joining materials to build a part, starting directly from the 3D model data. And this is quite opposite from the subtractive methodologies, where you are going to cut the material out to produce the part with machining, for example. And today, there are a wide range of technologies for additively manufacture a part, and there are so far at least 7 main categories of technologies of printing machine or printing processes, let's say. I will share with you the 3 most common. The first is the powder bed fusion. As the word suggests, we have a container with the powder, and then there's a plasma, an electron beam or a laser beam that is melting or sintering the powder material in the container. The second main category of technologies is what they call direct energy deposition. In this case, we have nozzles that are mounted on a multi-axis head, and from the nozzles, there's this ejection of powder, material powder, and the powder is melted with an electron beam, with a laser beam, while it's ejected from the nozzles. And the third main category of technologies is the material extrusion, sorry. In this case, the material is in a wire, and it is going through a nozzle, and in the nozzle is melted. And then there's the deposition, layer by layer, almost like an inkjet printer. So, of course, there are many other possibilities or many other categories, but those are the 3 main we want to share with you today. And when we talk about industrial sector and materials, we are talking usually about stainless steel, aluminum, nickel, cobalt, chrome, titanium alloys also, but we can go to print also precious metals with the 3D printing, with certain type of 3D printing machine. And this is what's happening. New machine builder are building different machines for different materials because of different performances you want with your process. And today there are a lot of known advantages, even if the technology started in the 80s and then is evolving, is entering in the industrial adoption. There are a lot of known advantages, and one of them is the possibility to create lightweight structures where the material is just where it needs to be, or creating or using more, less raw materials. But some of these aspects connected with the impact in the processes will be faced by my colleagues. I just wanted to close my short introduction saying that there are a lot of investments. We are involved in applied research projects funded by the European Commission, for example, and from the Swiss Authority for Research and Innovation. And just to make some examples, European Commission the last 2 years invested 95 million in research projects around additive manufacturing. And also China announced it in 2015, announced to invest 240 million in developing their own industrial additive manufacturing sector. So this is a very topic moment. There are a lot of unknown, as I said at the beginning, but there are a lot of investments to go into the general adoption of these new technologies. And now I want to leave the floor to Max. He will face a specific aspect connected with the environmental impact of additive manufacturing. Please, Max, mic to you.
Okay, thank you, Tiziano. Can you hear me fine? Okay, I'm Max. As a designer at Kimball, I've been focused my research on the environmental aspects of 3D printing, because I would like to accelerate the adoption of this technology, because I'm concerned about the planet besides the society. Now, among the many we can investigate together, there are three that has been, hitting my attention, and I would like to discuss them together with you. And they are decentralization of the production, and optimization of the resources, and waste management. Regarding the decentralization of 3D printing, since we can have a local 3D printing center, we're gonna see an increasingly development of locally produced and consumed services and products thanks to 3D printing. This means that we don't have to have a centralized factory producing and shipping parts all around the world. And if we think about it, what is the benefit for the planet and the environment? Well, if we can design, develop, and produce locally, we don't have to order from a distance and ship things around. The consequence of this is, of course, much less transportation. We have a less need to maintain vehicles, but most of all, we're gonna have less consumption of fuel, less traffic, less pollution, and hopefully less street accidents. So this is going to be very encouraging as an aspect impacting the environment. If we think about a possible future, since we can work in a decentralized way with 3D printing, think about maintenance and repairing. In that case, this is related to the project we are following right now. You're not forced to throw away the scrap part, maybe heavy metals, or to ship it for repairing, or to send a replacement part for something that just failed. You can do the opposite. You can send a team equipped with 3D printing technology and repair it maybe on site. Think about, for instance, the NASA that is having a projection about a possible future where we can print robots to construct habitats on Mars. Or maybe think about printing human organs in a local hospital instead of searching for transplant and other possible solutions. What is going to be in the future? Let's see together what is going to happen. It's going to be exciting. Second aspect was really interesting to see that by using 3D printing, you can have resource optimization. Because thanks to the precision and the flexibility of additive manufacturing technologies, we can have simpler designs by having less effort in the conceptual phase, but with more complex shapes, more powerful products. What's the benefit of this? You have less part required to be assembled to create your product, and this means that you're going to simplify also the production chain. What are the other consequences? You're going to need less molds and tools because you can have, automated chain and more modular production tools. You have, as I said, less parts required. The supply chain is shorter. What does it mean it is shorter? It means that you're gonna use less energy, less resources. This is important for the environment because we need to have savings in the usage of resources to have a better impact on the environment. In terms of a possible example, think about recently in the Netherlands, they 3D printed a bridge with concrete, and the actual concrete used was much less compared to the one needed to fill molds in the traditional way. Talking about the third and last aspect is the waste reduction, and I want to mention what Tiziano was suggesting about the differences between the traditional manufacturing process and the additive manufacturing one. In the traditional manufacturing process, you act more or less like a sculpture. You have a block or raw material, and you carve out the part that you don't need to get the parts that then you need to assemble to create a complex product. What does this bring is a lot of waste material, a lot of excess materials that you need to manage to throw away, and you have the concern of maybe recycling it or not. Well, in the additive manufacturing process, we are doing exactly the opposite. We are aggregating layer by layer material to be printed with the techniques that Tiziano mentioned. There are many of them. And by doing that, we can really optimize the waste to be produced. What are the benefits? Seems to be obvious that we're going to have less waste, less waste to manage, less excess material to throw away as a possible negative consequence for the environment. What about pushing this perspective even further? We have, for instance, NASA again that announced that in next year, 2018, they will have a completely recyclable product cycle for printing tools, thanks to plastic. They basically will use the material to print tools, and they will reuse it as a waste to print it again. And this is going to happen much more in the future, thanks to a lot of research that is, going on right now. So, as a conclusion, I have been, very excited to learn about the DIF and the circular economy. I've been following for several months, and that's why I felt like I wanted to be part of this to share my discoveries and my studies. There's one specific part very interesting to our works, our research, and even my personal life. That is, the value created in the circular economy has to be sustainable, especially for the environment, has to be resilient and long-lasting. Well, my suggestion, my proposal is that having seen the characteristic of additive manufacturing technologies, I would feel that it can be a key technology in a circular economy, especially thanks to the three aspects we have seen together that are the ones of decentralization of the production, optimization of the resources, and an improved waste management system. So a question to you, just to provoke a little bit of discussion. How do you see 3D printing in your life as a professional, as a researcher, as a human being, and as a part of the circular economy? It would be interesting to have your opinion. Now I would like to pass the mic to my dear colleague, Sophie. We have one question for her. So one of the effects of 3D printing is the decentralization of the production. Now, how does it affect the way how we can organize the work in the industry? Thank you for attention, and mic to Sophie. Bye.
Thanks, Max. Can you all hear me well?
Yes.
Fantastic. So we've switched from Rome to Lausanne, Switzerland right now. And like Max said, I'd like to explore more deeper what are the social impacts on a wide adoption of 3D printing. Perhaps just introducing myself, my role in Kimball is to measure and share the social impact of all the projects we are in, and especially the research project that Tiziano mentioned, and I will also mention later on. And for me, 3D printing is really a fantastic technology that is going to profoundly change manufacturing as we know it. And as I have a background in human resources, the question I've always asking myself during our research is how and what will be the impact of a wide adoption of it on the people working in the manufacturing industry. And so here are some thoughts I've gathered so far based on our research. And I'd like to first map the current system so that we can properly answer the question and see how 3D printing is changing the current system. So the traditional manufacturing system is based on two assumptions. First, the economic of scale principle, which is that the more you reproduce, the less it costs us. And the second one is the linear process that is supposed to be the most effective. So you hire people and train them for managing one line at the time. And these two assumptions have shaped the way work is organized in the manufacturing industry for almost a century now. And this has led to a pyramidal organization of work where there is a clear separation between the decision and thinking power in the hand of engineers and designers, and the execution, on the other hand, in the hand of the workers. And the consequence of this organization is that the cycle from having the first idea of the product and its industrial production is very long. So how is 3D printing changing the system? Well, when you give the possibility to engineers to directly make the complex product they envision and they imagine without constraint of time or manufacturing, then you create a disruption in the system. And just to give you a concrete example of that, one of the partners we have in our EU research project was able to make a turbine blade for energy production in 2 months instead of 2 years in the traditional manufacturing system. So the whole process of making new things is truly accelerated by 3D printing. And so if I come back to the initial question of how is 3D printing going to change the future of work in the industry, well, I'd like to share 3 main social impacts we can reasonably envision. The first one being relocation of work, because shorter production and consumption cycle directly implies that we can group places where we make things and places where we use things in the same location. So after decades of disindustrialization, we're going to witness a relocalization and reindustrialization of Europe thanks to 3D printing. The second impact is that we're going to have much smaller factories. So you actually no longer need this blue-white color dichotomy that has been the center of the old system that we inherited from Taylor. You have instead very skilled workers that are both able to design and make products that they have imagined thanks to 3D modeling, and they can quickly test in real life. So we are shifting the manufacturing mindset from what is feasible to what is possible. And the third impact is actually directly linked to that, is a need for upskilling the European workforce. Because with 3D printing, design capabilities are becoming an even more important strategic asset in a factory. So Today, we have clearly a shortage of skills regarding 3D printing designers. And this is why one of the EU research projects we are involved is putting a strong emphasis on education and training to enable the upskilling of the European workforce, especially in the SMEs. So if I summarize the three main aspects, I just cover the main social impact I see of a wide adoption of 3D printing. So relocation of work closer to the demand, much smaller factories with multiple skilled workers, and the need for upskilling the European workforce. Then the new question raised, and this is one for my colleague Helge in Norway, what will happen to the tailor's approach to manufacturing organization? Is the pyramid still the relevant model? Well, mic to you, Helge.
Thank you, Sophie. So we're trying to look at how does additive manufacturing impact our organizations. And the assumption that we're working on is that today's organizational system doesn't really fit the emerging needs of society and capitalism, because our organizations are built for certainty and efficiency. Now, in this system, you remove any object that creates any type of friction. So if that is an unstandardized part or a complicated process, a customer, or basically any non-robotic aspect of a human employee. So in this efficient system that we're a part of today, you could say that human labor is just an inevitable, it's just a temporary compensation for the inevitable machine. So as an employee, you're often hired into our systems as a talent, only to be put into a box where your talent and ambition doesn't fit. Now, even if you could see that these tides are turning, top management still seems very set on these ideas from the early days of mass production and Taylorism, and they continue to push forth an agenda of organizations that promote making individuals less important, and by that also turning work into something less relatable to the workers and less meaningful to the workers. Now, we believe this is about to change, and we believe additive manufacturing is a huge component on the industrial side of things for this change to happen. So the first things we are seeing is that advantage of scale has given us as consumers and employers much more. It's given us, so it's not a bad thing. Mass production, advantage of scale, it's given us increased material wealth. It's given us access to mass education. It's given us longevity of life, increased social complexity, all of these really good things. But the mass production system has enabled us as human beings to grow. But what happens as human beings grow is that we also come to demand much more things. And this is when the friction and this is when the problem starts to happen. So as we as human beings get access to all these new wonderful things, thanks to the economy of scale, and we start to demand much more from the business organization that we depend upon for consumption and employment. So these new demands, they haven't really been a part of the organizational toolbox. So organizations have had a blueprint that was tailored for mass efficiency, but it hasn't been tailored for meaningfulness, identity, and individualization. Now, these elements, identity, meaningfulness, and individualization, they are now essential to the output of any organization, but they are deemed problematic and irrelevant in the old system. So there's a huge conflict occurring. So and this conflict at the moment is between a new generation of employee needs and what the current organizational tools can offer. So that's the first. The second thing is that there's an increase in market complexity and market uncertainty. We are in an era where digitization has led industries to converge, to mutate. So a system that has been a mass production economy of scale system that's been built for certainty and predictability, which has been built for stability in certain times, is suddenly finding itself in uncertainty. So the whole model is not built to cope with the current situation that we're finding ourselves in. So the current model is unable to control for asymmetric relationships and that are appearing between our customers and employees and these new organizations. So the only thing in this system that becomes certain is uncertainty. And the third law is the iron law of industry, which is advantage of scale itself. So in the first point, I was talking about the the result of advantage of scale, now we're also looking at advantage of scale itself and how this will change. Because advantage of scale is also being disrupted. In fact, you can say that the scale is kind of turning into a disadvantage due to the massive cost of production of non-standardized parts. So companies come to other companies to demand much more individualization and non-standardized parts, and the current system isn't built for this kind of efficiency. It's not built for the flexibility that is needed, so advantage of scale is actually becoming a disadvantage. Scale, which once was, scale has been the massive or the biggest problem of barrier to entry for new companies, has turned into a barrier for incumbents to answer the demand patterns of the market. So as advantage of scale breaks down, every scaffolding around it also seems to shake or go down with it, which makes this a lot more interesting. So when the iron law of efficiency, which it's had a cost, it's cost individuals, ideas, talents, and meaningfulness so much. It's not come at a free price. It's a huge cost of this system to our societies and to our environment. And when this thing comes crashing down, we're now at this moment, we're given the opportunity to redesign how we organize and create together. And so the advancement of additive manufacturing is on a path to, you could say, it's softening the hardest kernels that there are in the midst of the industrial corporate landscape. The industrial machine is about to become flexible. It's about to become a tool for mass industrialization. This has a huge impact on industries around the world. With additive manufacturing, we are envisioning an ability for the industrial landscape to start delivering on the emerging demand in the market for identity and individualization. And so as we're moving from this organization design and train to make as little friction as possible, where people are situated into narrow compartments with clearly and precisely defined roles and goals, it's transitioning to an organization where friction, creativity, outliers, they have no added cost. They are in fact needed in order to be aligned to the emerging needs of the market. So we are imagining a radically different organization designed to output today what was not even imagined yesterday, as mentioned by all of my colleagues. We are entering a highly flexible world, demanding a highly flexible organizations. So the organizations that we're looking at, they're not linear. They are not based on hierarchies or chains of command or centralized decision making. In this new world, these new organizations, we're looking at decentralized teams making autonomous decisions, smaller companies because there's no advantage of scale, in local niches, and with the ability to turn around swiftly as demand patterns are manipulated by the new impulses. So those are our initial thoughts on the futures of organization. And then, Mike, to you, Tiziano.
Thanks, Helge. Thanks all of my colleagues. So we went through three main aspects of these new changes happening in the manufacturing industry. But for closing our session, I want just to connect with our role. We are involved in applied research projects for giving, yes, the social and environmental impact, but also the impact on the structure of the business itself. So I want to ask Helge, what's the future of the business in this new context?
Okay, thank you, Tiziano. So additive manufacturing and the future of business as we look at it. So we have to go into theory at this moment and to imagine a business as a set of components. So each component is like research is one component, manufacturing, assembly, distribution, sales, marketing, and so forth. So every organization is basically a string of components tied together in a value chain. And these components are all bound together by something that we theoretically call transaction costs. Now, the ultimate goal of a business, and this is what the business processes have been designed for, the ultimate goal is to have a superior system of efficiency and standardization, and to develop a sustainable competitive advantage. That's the main goal of almost every corporation in the world. Now, what we find is that with some superior technological advancements, and additive manufacturing being one of them, the models and practices that help companies sustain a competitive advantage starts failing. Now, there's a really good reason for this, and that is when the cost of interaction and transaction inside and between one component and the next, when this cost becomes zero, when there's no information, no communication inside these transactions, the cost becomes zero. And at that moment, and this happens at this moment, because when everything becomes digital and everything becomes scalable, this is basically what we're seeing. And so when the transaction costs come close to zero, then there's nothing left for the business to economize on. There's nothing left to take any money from anybody else from. And so the competitive advantage that an industry has built up over time or sustained over time suddenly becomes free. Now, to give an example of this, let's look at the encyclopedia industry, where the encyclopedia industry was quite a large, huge, impressive industry, but it put all its money on two main components, which was distribution and sale. And what happened was that the internet came along, and Google and Wikipedia offered the same content that the encyclopedia business did, but the problem wasn't the content. The problem was that it was online, which meant that there was no distribution, and it was free, so there was no sale. So just taking out those two, so a radically new technology comes in and just takes out two of your main components from your value chain, and then suddenly the whole industry becomes a novelty in just a couple of years. So how does this directly relate to additive manufacturing and a universal impact on business? Isn't this just a change from a sustainable to a fleeting competitive advantage? Well, I wanted to use a second comparison for this. So if you look at the industry of shipping and you look at the containers, so maybe 100 years ago, 80 years ago, if you were going to distribute something or goods, you had to take a truck and you had to fill it up with 30 to 50 individual packages. You had to go to a harbor, and then each of these packages had to be loaded individually into a net or into something else, and then lifted up into the boat. And this took enormous amounts of time. So this guy came up with an idea, and he said, why don't we just put all the small boxes into a larger box on the lorry, and then the crane could just pick up this one box and just lift this one box in one go onto the ship. Magnificent improvement. This is the birth of the shipping container. Now, this first wave of shipping container innovation wasn't really the big thing. What happened was that it dramatically improved efficiency, it dramatically improved turnaround times, and it reduced the cost of shipping, which was really good. But when this one company started doing it, and they made their life much more efficient, then you got the second wave, which is that all other shipping and freight industry actors started doing the same thing. So you got redesigns of boats and you got redesigns of harbors. But still, it was just improving the efficiency and reducing the cost of shipping and just improving these two industries. But then, as you did that, you dramatically reduced the cost and the cost of transporting goods globally. And this is when the game changer happens. This is the third wave, because it was only when freight became efficient and cheap enough that global trade as a concept could offer businesses around the world an accessible product. So the advent of globalization emerged because of the invention of the container. But it wasn't in the first stage, it wasn't in the second stage, it was in the third wave of development. And now suddenly every company in the world is touched because of this container design, and it has unleashed, for companies around the world, it has unleashed enormous new markets. It's grown and expanded far beyond the shipping and the freight industry. And we think that additive manufacturing is also such a technology. It has different advantages and barriers, of course, but it's not game-changing because of the first iteration that we're seeing at the moment. It's not game-changing because of prototyping or spare parts manufacturing, of course not. It's not even in the second wave that we're going to see huge improvements and change at a large scale, with the second wave being the optimization of supply chains and the simplifying of sourcing of materials. But it's in the third wave when the advantage of scale disappears due to the constant cost of production and because of individualized production capabilities. This is when we're going to see a massive change on a global scale. This is where we're going to, this is when we think and we hope we're going to see a move from businesses and companies away from the globalized hymn of mass production and to a much more localized production and to a much bigger growth of niche markets. Now, of course, there are obvious hurdles to overcome. We need improved processes for all printing methods. We need stronger and more durable materials, and most of all, we need much more speed. But we are convinced that within a few years, this advantage will be overcome by developments in technology. So the business models and practices we know today, they were designed to fit the technology, the barriers, and the demand patterns of when these models were designed in the first place, which is 90 years ago. But as the world has changed, the model the model that was designed to fit this world has to change as well. We need to change our business processes to fit the new world and the new markets. Just to give a few examples of the capabilities of additive manufacturing. First, using additive manufacturing for rapid prototyping is already well established. Sophie was touching on this, allowing companies to work with many, many more iterations at a much higher pace. This dramatically improves the ability to do increased experimentation, and increased experimentation will allow for new ideas and new products to emerge. Secondly, the additive manufacturing technique itself allows for the shaping of internal and external components. It's an additive method. It's not a subtractive method, as Tiziano was touching on, which allows for engineers and designers to think of what was previously completely impossible with the subtractive techniques for molding and milling. This invites our imagination to explore and find new structures that can provide exponentially increased quality of both weight, strength, and design. Thirdly, with digital molds, we're adding the opportunity of making individual changes to the production at no cost. With this kind of individualization, additive manufacturing is a much better product market fit than the generalized mass production products that we're seeing today. And so we're removing, basically all of these things are slowly but surely removing all the economic advantages for a business to do mass standardization. And as businesses no longer can rely on the advantage of scale, the need to scale is gone. We don't need global corporations because there's no more money, no more margins to be earned by going big. And so we will see a reduction of barriers to entry unleashed by a storm of small companies with brilliant ideas for how to solve known and unknown problems. Now, finally, it's in our minds that it's our minds, not our capacity to buy tooling equipment, that is going to be the greatest competitive opportunity forward. A set of small businesses allows for a much more flexible, a much more adaptive market that will be rigged in favor of small players, not big players. With additive manufacturing, we're opening up one of the locks that have held the business hostage to the mass production model. We are now much more freer to design, not for scale, but for creativity, to design for ingenuity, and to design for talent. We think business will return from mass captivity to its fundamental nature, which is giving talents a platform where they can imagine and feed new ideas to the world. Thank you.
Thank you, Helge. And we have some questions coming in, so I think it's a good timing to go to the Q&A. For everybody watching online, this is your moment to ask all your questions, so post them in the discussion box underneath this video. First question that we have in is from Elisa. And she talks about, she mentions that you've talked about skill as one of the roots of the current manufacturing industry. And with 3D printing, how do you see 3D printing scale up with regards to decentralization that you have mentioned before? So I think also with having the flexibility in mind, is skill in this picture with 3D printing, or is it not about scaling anymore?
Is it about skill? Yeah, Tiziano.
No, please. If you want to go, Helge, no problem. No.
My question was, did you say skill or scaling?
Scaling.
So scaling is you can go. Scaling is not a problem with this. You can go large scale as the same as today, but there are the increased advantages outside of scaling that is going to give businesses the biggest change. Tiziano.
No. I'm quite good. I'm quite good with your answer. I didn't get the first question. That's it.
All right, Helge, so you mentioned that other opportunities more important than scaling. Can you quickly elaborate a bit on that?
Okay, so I wouldn't say other. The reason we mentioned scaling is because the system today has been built for advantage of scale, and the current model for producing, in order to get advantage of scale, you have to standardize and make things more efficient. And this has a huge cost to everything but the efficiency itself. And so what we're saying is that if you want to use your 3D printing machines to do massive scale, the same component, then it might not be the most logical, economical alternative at the moment, because massive scale is still much more cheaper to do in the traditional method. But if you want to take advantage of the other opportunities from 3D printing, which you mentioned, which is the ability to build radically new models, to rethink how we build everything from faucets to buildings to bones, bone marrow, or to do rapid prototyping in a much higher scale to give us the tools to imagine completely new ideas, or we will see a use of completely new materials as well, enabling new opportunities. So I think the future is not in front of us. It's not like we're going to choose 3D printing to go faster forward. The future is outside. And so in order to grab all these opportunities and potentials that are outside the current model, that's why we're looking at 3D printing. It's not to make a more efficient mass scale production.
Okay, thanks for your answer. I think it's really interesting to see that we're just having so many more factors to take into account than only scaling up. And that's a great opportunity from 3D printing. We have another question coming in from Lisa. It's a quite long question, so I'm going to read it through. I read in a report by ING Bank that 3D printing could cut world trade by 25 to 40% in the next 40 years. Good for areas with a manufacturing trade deficits, but bad for places with a manufacturing trade surplus. This will massively disrupt current global employment patterns. We will likely see a rise in employment in trade deficit countries, but a stark rise in unemployment in these manufacturing trade surplus nations like Mexico and China. What do you imagine will replace these lost jobs? Do you guys think this is where universal basic income comes in to soften the blow?
I can go with this, if I may. And let's say that we don't know for sure, of course, because something is happening right now. But I agree that there will be some changes in the employment structure of our world. But when you refer to Mexico or China, it seems like we are referring to passive countries that are just waiting the other part of the world, their decisions. So as I said at the beginning, China is investing 240 million to create their own in that industry with additive manufacturing. So first of all, it's a dynamic moment. So it's not happening just in this world, it's happening everywhere. So I think that Mexico and China, we will start to take some advantages from additive manufacturing itself. But then, of course, there's not only additive manufacturing as trait to employment or to change the way we employ people. There are other technologies like automation, for example, or robotics. We are involved in a couple of projects too. But let's say that the topic of basic income is popping up more frequently, and there are different voices around this specific topic. Of course, we should change something broader to say, okay, we are moving from a civilization based on production to a civilization based on use or enjoying products that machines are building. So the basic income could come, maybe as Helge said, in the third wave of evolution of these new technologies that are disrupting or changing the way we make things, we produce things. So maybe yes, for my personal opinion, I think this will happen, or something like what's happening right now, or what people are talking about around the basic income, but it will be something like that, yes.
All right, interesting to hear your opinion about that. I think we we're kind of running out of time, so it's probably time for our last question. That's a question coming in from Blondine for Florent. She asked, globally and now, are 3D printers such as good technology for our planet? And she adds a little comment below that. Sometimes you cannot have the same resistance of material, and so you need to use more material. Sometimes you have more loss of production because a 3D printer is not so performing.
Okay, I can go, guys, if you want. Okay, thank you. For the first part of the question, is it good for our planet? I think so, and we are, in this very moment, what's happening? In this very moment, we are witnesses, we have witnessed the movements from the science to the technology and then to the market. In this very moment, we are participating as first eyewitness in the struggle of scientists in building technology that will enter the market itself with entrepreneurs. And I think our effort in this very moment, introducing social responsibility or environmental impact, will create some good technology for our planet. And this is part of our contribution to the research project in transforming science into something actually spread, adopted. For the second part, the technology, the 3D printing, the wide range of methodologies to 3D print things are evolving. Last week or 2 weeks ago, we saw on Science a news say that a 3D printed process strengthens twice the stainless steel resistance. So we are going to produce things more performing than the others because of different process, different things. So also the ability of these new technologies to reproduce or to match the strength, for example, of the old processes like melting or casting is very thin. It's happening every day. We are eroding this imbalance. So nowadays, a lot of method to 3D print something is overcoming the performances of traditional manufacturing processes. And that's it.
All right, thanks a lot for all your answers and the great conversation you had going on. I think it was very interesting. We had another question coming in online, so maybe you can have a look and answer it later on online. So that's it for now. Thank you, and thank you for everybody viewing online. We have a session coming up later today, and that's about the circular design case that we started last week. Circular design case gives everybody the opportunity to explore how circular design works, and everybody can pick one object and put it into a system, so new opportunities of redesign come through. We're gonna have a check-in today on circular design, and maybe a nice thought for that is how can we use 3D printing to make to redesign products into a circular way. That's it for me for now. Thanks a lot, everybody, and goodbye.
Thanks to you. Bye.
Bye to everyone.
Thanks, everybody.